Shri Gurubhyo Namaha, children. Today we are going to continue with the second part of current electricity. Hope you went through the introduction concepts regarding electric current. We discussed yesterday that electric current is nothing but movement of charges, and we were also discussing about the formula for electric current, which was found to be I is equal to dq by dt. So this is what we discussed yesterday. Now today, and I was also discussing about the introduction of drift velocity. Now whenever you give an electric field or whenever you connect a metallic conductor to a battery, the electrons, the free electrons that are there in the conductor will start drifting towards the positive terminal of the battery. This is what we were discussing. And whenever an electric field is given, I told you the electrons get accelerated. Okay, they gain a force, they experience a force which is given by F is equal to E into E. Now this is as I told you yesterday, this is from the formula electric field equal to force experienced per unit charge, or charge is equal to E into force is equal to E into Q. Now here this Q is replaced by the electron. So whenever an electric field is given, the electrons, they experience a force and they get accelerated. After they get accelerated, they start moving with a constant velocity, which is called as drift velocity. Before the uh, presence of the electric field, the electrons were randomly moving, but here after they gain the electric field, they get accelerated and start moving towards the positive terminal of the battery. So they experience a force when an electric field is given, and they get accelerated, whose value is given as A is equal to, acceleration is, what is the formula for acceleration, children? Acceleration is, now from this formula, F is equal to, we know the force formula, F is equal to ma, or A is equal to F by m. So substitute the value of F as E into E by m. So this is the acceleration they gain. So since it is a vector, I will write the symbol. So acceleration, and we are going to substitute the formula for drift velocity. Drift velocity is nothing but, velocity formula is acceleration into tau. Okay, acceleration time, tau is nothing but the time interval between two successive collisions. Yesterday I was explaining you. Now what is the time interval between two successive collisions? It is also called as relaxation time. So this is the formula for drift velocity. Substitute for the acceleration value. So Vd is equal to, substitute for A as E into E by m into tau. Okay ma? Is it clear? So here it is again vector. So I will replace Vd as E tau by m into E vector. Now this E tau by m is given as mu. Okay, so what is this mu? Mu is nothing but, you call it as mobility. I'm going to replace by a constant, because all these are constants. Whether you take E, whether you take tau, whether you take mass, he is the charge of the electron, tau is the time interval between two successive collisions, and m is the mass of the electron. So all these are constant values, and I replace it by a constant called mu, which is called as mobility. So what is mobility? I will write the formula for mobility now. Now here Vd is equal to mu times E vector, right? I'm going to substitute, I've substituted E tau by m as mu in this equation. So this equation becomes Vd is equal to mu times E vector, or I can also have the formula for mobility as mu is equal to Vd by E vector. So this is nothing but mobility, which is nothing but drift velocity acquired per unit field. Listen, what is mobility? Based on this formula, I will write drift velocity. Drift velocity per unit electric field is nothing but you call it as mobility. Okay, and we will write the formula for mobility as what is the SI unit? Sorry, mu is equal to Vd by E, right? So Vd is velocity, children. So velocity unit is meter per second, and electric field in terms of V by D can be given, right? Electric field E is equal to V by D. So V is measured in volt and D is measured in meter. So I have volt, meter will go to the numerator. So here is the unit for mobility, which is meter square per volt second. Okay, so this is the unit for mobility. So all these things you should know, children. Okay, very, very important formula. Okay, is it clear, children? Now this drifting, the drifting velocity, when we talk about this drift velocity, the drift velocity in a metallic conductor is found to be, there is a paragraph in page number 86, children, under this SI unit for mobility. Under that there is a note they have given where they talk about the drift velocity of the electrons. This is very, very important, children. Actually, they have given the value of drift velocity of electron to be 10 power 4 meter per second. Okay, now actually this is very, very slow, right? 10 power actually this is given as 10 power minus 4, children, not plus 4, it is minus 4. Okay, so which means the speed of the electron is 10 power minus 4 in the sense 0.0001, which is very, very slow. Okay, the speed is very, very slow. So in that case, if an electron drifts with the speed, then the electrons leaving the battery will take hours to reach the light bulb. So when you connect a battery and a filament bulb, by the time the electron starts moving from the battery and reaching the bulb, the time taken will be very lengthy time, because they move with a speed of 10 power minus 4 meter per second. They move very slowly. But how electric bulb glows as soon as we switch on the battery, but immediately when you switch on, immediately the battery glows. But the movement of electrons, actually we say that movement of electrons is nothing but current. So when the electrons move in a very slower rate, then how come when you switch on the when you switch on, immediately the bulb goes? The reason bulb glows, the reason they give is, see there, when the battery is switched on, the electrons begin to move away from the negative terminal of the battery, and this electron exerts force on the nearby electron. So what is experienced by the electron as soon as an external energy is given? It experiences a force. This is what we saw. The force experienced by an electron is given as F is equal to E into E, right? Now this process creates a propagating influence that travels through the wire at the speed of light. Now look at the explanation they are given. When one electron starts experiencing the force, that is instantaneously transferred to all the electrons, and this transfer of energy takes place with the speed of light, which is considered to be very fast. You know the value of speed of light, which is 3 into 10 power 8 meter per second. So that is the time where the electron, that is the speed in which the energy is transferred from one electron to the other electron. I read that sentence again. See here, when a battery is switched on, the electrons begin to move away from the negative terminal of the battery, and this electron exerts force on the nearby electrons. This process creates a propagating influence that travels through the wire at the speed of light. Propagating influence, in that sense they talk about electric field there. Okay, in other words, the energy is transported from the battery to the bulb at the speed of light through electric field. So the force that is experienced, that electric field, that energy from the battery to the light is traveled very fast. Okay, so due to this reason, the light bulb glows as soon as the battery is switched on. Although the drift velocity of the electron is considered to be very slow, but still instantaneously when you switch on, the bulb glows. This is the reason for this. Okay, superb concept. You have to understand. No use of just doing the derivation. No, that and all, it will not work. You have to analyze the concept and think. That is physics. Then only the subject will be interesting. Okay, so involve yourself in learning a subject, understand, be curious to know about the facts only, then you will start liking a subject. Physics is one type of subject. Unless and until you have the passion to learn, unless you are inquisitive, it becomes very tough. Okay, so with this we are moving on to the next topic, which is microscopic model of current. Now before that topic, there are two concepts that are discussed, children. Actually, it is in the topic misconception. They talk about what do we think about. We think that battery is nothing but battery produces electrons. That is a misconcept. Battery does not produce electrons. What does battery do? It produces energy. Now that energy is used to move an electron in the conductor. When the battery is connected to an external when the battery is connected to a metallic conductor, it is the energy of the battery that is used to move the electrons in the conductor. Actually, battery is not producing charges. The second point is, whenever we talk about charging the battery in my mobile, we use these terms, charging the battery in the mobile, which means that what? Charging the battery means it is wrong. You cannot say that battery is charging. We are not giving charges to the battery. What is given? What is given is energy. Okay, so adhe mari when you go to the electricity board, we are paying the current bill solro. Current bill is nothing but not for the current we are paying. We are paying the bill for the electrical energy that is used by us. So electrical energy is different. We are paying the amount for the electrical energy that is consumed by us, not for the current. So there are some terms which has to be corrected. So go through that topic. You can understand very easily. Just I have already told you. Just once read it. Okay. So with this, we are going on to the next topic, which is called as microscopic model of current. Now there is conductor again. There is a metallic conductor, and this conductor is connected to an external battery. Actually, that is not there. You have to understand. See here, electrons are moving from left to right. Now this is drift velocity of the electron. So in that case, what will be the direction of electric field? The electric field will be in this direction. Now imagine this conductor to be connected to a battery, positive and negative terminal of a battery, so that the electric field will be in this direction. Hope you understand the diagram. Okay, and the length of the conductor is given as dx, which is v into dt. Okay, distance is velocity into time. So dx is vd into dt. So I'm going to consider a conductor, and A is the area of cross section of a conductor. So I'm going to find out the relation between current and drift velocity, right? So again, I draw the diagram somewhere here, children. A metallic conductor. Okay. Now this is connected to a battery, so that the electric field will be in this direction, and the electrons, they drift. Now this is electrons. Now they drift towards the positive terminal of the battery with a velocity Vd, and here this is the length of the conductor, whose length is given as Vx dt. Okay, velocity into distance. Sorry, velocity into time. Actually, the formula is velocity is equal to, what is the formula? Velocity is equal to distance by time. So distance is velocity into time, length, which is the length of the conductor. Okay, so let us start the derivation part of it. Let us consider there are n number of electrons. Let us consider that there are n number of electrons per unit volume of the conductor. So let me start with the derivation part of it. Number of electrons per unit volume is equal to n. Now this is called as number density. Number of electrons per unit volume is nothing but call it as number density, right? The next one is drift velocity. Of course you know this. Drift velocity of the electrons is Vd, right? Okay. Now what is the distance here? Vd is equal to dx by dt. You know the formula for velocity as distance by time. So with this I will take the value of dx to be Vd into dt, which is the length of the conductor. I have already written this. Dx is equal to Vd into dt. And of course area. A is the area of cross section. Area of cross section of the conductor. Okay ma? Right? Let us find out first what is the total number of electrons. We'll say that electrons are there. So how many electrons are there? Total number of electrons is, how do you find out? Number of electrons into volume of the conductor, right? So how many electrons are there in this conductor into volume? Volume of this conductor into n, which is nothing but number of electrons per unit volume. Per unit volume abdina, listen, take a very small area of cross section. Now how many electrons are there in this section is given as n. So n into the volume of the conductor is nothing but total number of electrons. Hope you are able to understand this. That's what I wrote here. Number of electrons per unit volume அப்படினா 1 meter cube volumeல எவ்வளோ electron இருக்கு? That is n. That value multiply by the length, the volume of the conductor will give you the total number of electrons. Yes or no? Okay. So what is V here? Now V is nothing but volume of the conductor. So what is volume formula? Volume formula is area into length, right? So area into length. So n into a into length is nothing but dx, right? So in the dx small distance. So into dx badala I substitute vd into dt. Am I right? Yes, so Na, Vd, dt is the total number of electrons. So if this is going to be the total number of electrons, what is the charge? So charge in volume element. Volume element dq. What is the charge? இப்போ இதில charge என்னவா இருக்கும்? What is the charge here? So charge is given as dq, which is equal to charge of an electron into the number of electrons NaVd dt. So this is the charge. Okay, and we know the formula for current now. So current I is equal to dq by dt. So what is dq? NeaVd dt divided by dt. So again dt gets cancelled. So here is the formula for current which and drift velocity. This is the relation between current and drift velocity. I is equal to NeaVd. Now this may be asked as a 3-mark question. Derive an expression for relation between current and drift velocity. So when this question is asked, you need to arrive up to this definition. Okay, up to this derivation. I is equal to NEAVD. Very, 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 how many times you write important, you write, no problem. Very, very important derivation, which relates, this derivation relates current and drift velocity. Current is directly proportional to drift velocity. Okay, greater the current, greater will be the value of drift velocity. Is it clear? Is it clear, children? Next, we are moving on to current density. So, what is this current density? Okay, current density, this is represented as capital J. Okay, so again, current density, here it is a vector quantity. Whenever we talk about current density is a vector quantity. Okay, so it is defined as, what is current density? Current density is defined as current per unit area of cross section. The current per unit area of cross section is nothing but, you call it as current density. I will write the formula for current density as J is equal to I by A. Now I is unit for J. J is, current is measured in ampere and area is measured in meter square. So the unit for current density is ampere per meter square, and this is considered to be the vector quantity. So here is the formula for current density. J is equal to I by A. Suppose this is a conductor. Okay. Now consider a small area. How many number of charges, or what is the current through this area? Okay, now this area is perpendicular to the electric field. So what is the current flowing through this per area? As I told you, when we were discussing about a steady current, when we were talking about instantaneous current, depending upon the area at times may be not uniform. In that case, the number of charges flowing through this area will be different. So in that case, the current also will vary, right? So that is why we talk about area here. Okay, current flowing at a particular area. Okay, it is defined as current. This may be different. The current flowing through this area will be different. If I take this paper, if this is going to be the area, when compared to this, the area of this is more. So the current will be more here. So current flowing through per unit area of cross section is nothing but, you call it as current density. Okay, ma? And we know the formula for current now. What is current? I is equal to NEAVD. Substitute in the formula. J is equal to NEAVD divided by A. So A and A gets cancelled. So here is the formula for current density, which is NEVD. Again, one more formula. J is equal to NEVD. And as I told you, J is a vector. I can write vectorially as J vector equal to NEVD vector. Okay. Now we know what is the value for drift velocity. So what is drift velocity formula? Vd is equal to, we have already derived drift formula. Drift velocity formula is Vd is equal to minus E into E by M. This is what we arrived. Yes or no? This is the drift velocity formula. Last topic we discussed drift velocity based on F by A formula, F by M formula. So this is drift velocity. Substitute here. When you have substitution here, N into V into, what is drift velocity? Drift velocity is E into E by M into tau. So how this formula goes now? With a negative sign, right? So J can be written as minus N E square, right? Okay. Then constants and all I will segregate today, this time. Okay, this time. So N E square tau by M into, this is the variable. Okay. So these are all constants, and this constant is replaced by what is called as sigma. So sigma takes the value of Ne square tau by m. So current density will be equal to sigma into E vector. So what is this sigma? We'll give a name to sigma. Sigma is nothing but you call it as conductivity. I'm coming to the next important word, conductivity. Sigma is called as conductivity, whose value is Ne square tau by m. Okay, so this is the derivation part. This is from current formula, current densities. We are arriving at some formula which is J vector equal to sigma into E vector. Okay, so this is called as conductivity, and this is also the microscopic form of Ohm's law. We have not gone to the macroscopic form. We are going to that. Now through this current density and current formula, we are relating current density and the electric field by this term which is called as conductivity. Now go through all the topics we have discussed. The first topic we have discussed is relation between current and drift velocity. The second one is we defined what is called as current density. Current density is nothing but current per unit area of cross section, which is given as J is equal to I by A. And using the values for drift velocity and current, we arrived at a relation between current density and electric field, which is given as J vector equal to sigma into E vector. Okay, so this is what we discussed, and there are few examples based on this, children. Okay, in your book, page number 84. Now page number 84, there is an example 2.1. 2.1, compute the current in the wire if a charge of 120 coulomb is flowing through a copper wire in 1 minute. So the time given is 1 minute. Charge is 120 coulomb. So you need to find out the value of current. So value of current I is equal to Q by T, which is 120 by 60, 2 ampere. Okay, very simple sum. Then the next example is in page number 86, which is example 2.2. I read the sum. If an electric field of magnitude 570 Newton per coulomb, so the electric field value is given as 570, and the charge of an electron, of course you know, E is equal to 1.6 into 10 power minus 19 coulomb, and mass of the electron is 9.11 into 10 power minus 31 kg. What is that you should find out? You should find out the value of acceleration experienced by the electron. So what is acceleration? So acceleration A is equal to E into E by M. So substitute all the values. When you simplify, you will get the value of acceleration is 1.001 into 10 power 14 meter per second square. Very simple sums. It may be asked as a 2-mark question, children. Okay, and go to the next page, 88. Page number 88, you have example 2.3 and 2.4. Now a copper wire of cross-sectional area 0.5 millimeter square carries a current of 0.2 ampere. If the free electron density of copper is 8.4 into 10 power 28 meter cube, then compute the drift velocity of free electrons. Now the relation between drift velocity and current is I is equal to NAEVD, right? Now here the question is, you are supposed to find out the drift velocity of the electron. So what are the values given? They have given the value of area of cross section, current value is given, and N is also given. So N is also given. So when you substitute, you have to rearrange the formula. VD is equal to I by NEA. So simplify for I as 0.2 divided by number of number of electrons is 8.4 into 10 power 28. Charge of an electron is 1.6 into 10 power minus 19. Then 0.5 is given. Okay, area of cross section, right? So when you simplify, you will get the value of drift velocity. Okay, ma? Is it clear? Right. The next is example 2.4. Determine the number of electrons flowing per second through a conductor when a current of 32 ampere flows through it. So current is given as 32 ampere, time is given as 1 second. Per second they have given. So charge of an electron, of course you know, charge is 1.6 into 10 power minus 19 coulomb. So the number of electrons flowing per second you need to find out. N we need to find out. So I is equal to Q by T. Okay, Q is equal to Ne, right? Q is not given, so instead of Q we substitute Ne. So rearrange the formula. N is equal to IT by E, substitute and you will get the answer. Okay, so work out these problems, 4 problems you will work out and send me as homework. Apart from that, one more question which I will give mark and give you from the first chapter. So this is your homework for today. Please go through all the concepts whatever we have discussed so far. So many formulas we have discussed. I want you to go through each and every formula. Okay, see you tomorrow, children.